Hi guys, thanks for checking my channel. Today we are going to see how to deploy Prometheus, NodeExporter and Grafana inside your Kubernetes cluster. Before I start this video, I would like to remind what's not part of the scope of this video. In today's discussion, I'm not going to explain in detail about the Kubernetes architecture, that is Kubernetes resources like nodes, pods or services in detail. I'm also not going to explain about Kubernetes YAML files in detail, that is the configuration files that we need to write for creating Kubernetes deployments, Kubernetes services and so on. I'm also not going to explain about the Prometheus or its architecture in detail, and also I'm going to skip the explanation of Grafana and its architecture in detail. In case if you are new to all these systems or concepts and if you would like to get started with these things, I have provided some links in the description where you can find some good resources to get started. So what we have for today's agenda. First, we will prepare our setup for the Kubernetes cluster. In this video, I'm going to use minikube, which basically provides a one-node Kubernetes cluster that you can install on your local machine and start deploying your applications inside the Kubernetes cluster. We will also see how to install 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐿, also called as kubectl, which provides a command line interface for communicating to your Kubernetes cluster. Then we will install Lens, an application that provides a very powerful and interactive UI for communicating or inspecting your Kubernetes cluster. Basically, you can use Lens and perform all the activities that you would perform with 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐿 and save a lot of time. Then we will see how to deploy a simple Prometheus server application, or simply called as Prometheus, inside your Kubernetes cluster. Then we will see how to deploy a simple NodeExporter application inside your Kubernetes cluster. In case if you are not sure what is actually a NodeExporter is, then we will also see about its explanation later in this video. Then we will see how to add this NodeExporter as a target to Prometheus, that is how to make Prometheus pull the metrics from the NodeExporter system. And then we will deploy a simple Grafana server application inside your Kubernetes cluster. And finally, we will see how to create dashboards for viewing the metrics of the NodeExporter via the Grafana user interface. So let's start preparing the setup for our Kubernetes cluster. As I mentioned before, I'm going to use minikube for this video. Minikube is basically a one-node Kubernetes cluster that you can install on your local machine. So just go to Google and type minikube. If you go into this page, you can find all the information for installing the minikube on your local machine. So in case if you are using Mac OS, then you can install minikube simply by means of brew, that is brew install minikube. Please be aware that if you want to install minikube on your local machine, then you also need to have a driver installed on your local machine, like a Docker or VirtualBox. By default, minikube will be using Docker as the driver. So in case if you're using Docker as the driver, then make sure that Docker is already running in your machine. So when you execute this command, then minikube will be installed. I've already installed minikube on the machine. So to check your installation, just type minikube version. So minikube is installed on my machine. Also, when you install minikube, 𝐃𝐄𝐒𝐂𝐑𝐈𝐏 will also comes as part of the installation. So 𝐃𝐄𝐒𝐂𝐑𝐈𝐏, as I mentioned before, is a command line interface for communicating to your Kubernetes cluster. So you can check whether 𝐃𝐿 is installed or not by typing the command 𝐃𝐿 version. So 𝐃𝐿 is also installed on my machine. So now you need to start the minikube on your machine. Just type minikube start. In case if you are executing this command for the first time, then what will happen is the Docker image for the minikube will be pulled into the system, and then the Docker container for the minikube will be started. So I've already started the minikube on my machine. So if you execute Docker images, then you can see that the Docker image for the minikube is pulled into the system. And similarly, if you type docker ps, then you can see that minikube is running inside the Docker container. Now you can start checking the configurations for all the Kubernetes clusters available inside your machine. So just type 𝐃𝐿 config view. So you can see the list of Kubernetes clusters installed on your machine. So we have installed minikube, right? So I can see this minikube cluster, and also I can see a context called minikube. So we have to first set the current cluster as the minikube cluster. So for this, we can type 𝐾𝐿 config set cluster minikube, and then we also need to set the context. So for this thing, we have to type 𝐾𝐿 config use context minikube. So now we have prepared the setup for our Kubernetes cluster. So if we go back to the agenda, the next step would be like to install Lens for inspecting the Kubernetes cluster. So just go to Google and type Lens for Kubernetes. Just go to this link and then you can install the application for your respective system. So I've already installed Lens on my machine. So once you install Lens, this is how the Lens looks like. So if you open the Lens and then go to this topic called clusters, you can see all the Kubernetes clusters installed on your machine. So we have installed minikube, right? So we can see that minikube cluster is available. Just click this thing, and when you click this thing, you can see the entire Kubernetes cluster via your user interface. So you can see like what are the pods available inside your Kubernetes cluster. Of course, we don't have any pods running so far. And also you can see what are the deployments, what are the jobs, what are the daemon sets, what are the config maps, and all those things. So if you're using Lens, you can basically perform all the activities that you would perform via kubectl. Basically, Lens helps you saving a lot of time whenever you work with Kubernetes. Now, before starting to deploy Prometheus or Grafana, whatever it is, let's create a namespace inside our Kubernetes cluster. So let's check what are the namespaces available. Kubectl get namespaces. So we have like the default namespace and all other system related namespaces. So let's create a new namespace. Kubectl create namespace. Let's call our namespace as DEM, Data Engineering Minds. So the namespace DEM is created, and now let's set this DEM as the default namespace. So kubectl config set context. So we are going to set the namespace DEM as our default namespace whenever we are going to deploy anything inside our Kubernetes cluster starting from now. So we are going to set this namespace inside our current context, and the namespace name is DEM. So now when you start deploying your applications, everything by default will be installed or deployed inside the namespace DEM. So you don't have to specify the namespace every time. For example, if I want to see what are the deployments available, I need to type kubectl get deployments and then specify namespace which is -n and then DEM. So of course there is no deployments deployed so far in this namespace, but since we have set DEM as the default namespace or the current namespace, we can simply skip this command, and you see it will already like start querying the DEM namespace. So now we have created the namespace. Let's start deploying the applications one by one to our Kubernetes cluster. So the first application that we are going to deploy is the Prometheus. So what are the steps to deploy a Prometheus server application inside Kubernetes? So the first step is we need to create the Kubernetes deployments for the Prometheus. Basically, the Kubernetes deployments will launch the actual Prometheus applications, which we also call as pods in Kubernetes. And then we will create the service for Prometheus. So basically, the service will allow us to access the Prometheus user interface via the internet. So let's start creating the deployments for the Prometheus. So first let's create a folder called Prometheus. So we will use this folder to put all the Kubernetes components for the Prometheus. So the first component that we are going to create is the deployment. So let's call it as Prometheus deployment.yaml. So now to get a sample deployment file for Kubernetes, just go to Google and type Kubernetes deployments. So if you go into this link, you can find a sample deployment file for Kubernetes. So sample deployment file for any application. So just go to this Prometheus deployment.yaml and paste this thing. So if you look into a deployment file, basically it contains two parts. So the first part is the configuration for the deployment itself, and the second part is called as template, which contains the configuration for the pod. So what is actually a pod? Pod is actually an abstraction on the top of a container. So when you install any or deploy any application to your Kubernetes, this application will be running inside a container like a Docker container, and pod is an abstraction on the top of the container. So when you want to access your application inside Kubernetes, this means you will be accessing the pod and not the container. Let's first start configuring the pods. So if you look into the template, there are two parts. The first part is metadata and second part is spec. The metadata part contains a field called labels. So label is actually a key value pair that Kubernetes uses to identify an application. So if you, we are going to deploy a Prometheus application, right? So let's call the app name as Prometheus. And the next one is the spec or specification. So inside the specification, we actually specify the container information for the application. So we are going to deploy a Prometheus application, so we need to specify the Docker information related to the Prometheus application. So let's go to the Docker Hub page and search for Prometheus. So basically you can find several images for Prometheus. I'm going to use the first one, which is Bitnami. So if you want to install, pull this image for Prometheus, you have to specify Bitnami Prometheus latest. So let's go to this container part. Under the container, you can see name. The name is going to be Prometheus. And then for the image part, let's paste Bitnami Prometheus latest. And by default, Prometheus will be running on the port 1990. So let's use the same port. So now we have specified the container information for the Prometheus. So with this, we have specified all the configurations for the Prometheus pod. Now we have to specify the configuration for the actual deployment. So like the pod, the deployment also contains two parts like metadata and specification. So under metadata, you can see the name. So let's call it as Prometheus deployment. And then we have like label. So label for the deployment is completely optional, whereas the label for the pod is mandatory, but for the deployment it is completely optional. A deployment can have several pods inside it, but for our use case, we are going to have only one pod, which is called as Prometheus. So let's use the same name, Prometheus. And the next part is specification, but before that, so we have specified the Prometheus deployment, and we want this deployment to happen inside the namespace DEM, which we created earlier. So let's put namespace and then DEM. So then the labels is completed. Now specifications. So replicas is how many instances of Prometheus application we want to run inside Kubernetes. So let's keep it as 2. So this means like 2 different pods for Prometheus application will be running inside the Kubernetes. The next field is called as selector. So basically this selector field will help the Kubernetes to understand which pod needs to be tied or mapped to this deployment. So we have this label called app Prometheus for the pod. So we are going to map this pod to this deployment. We can do this by means of this label called, this field called match labels. So just under the match labels for app, type Prometheus. So basically this allows Kubernetes to understand that this application called Prometheus, basically this pod called Prometheus belongs to this deployment called Prometheus deployment. So this field is very important to map the deployment and the pod together. So now we have created the deployment for the Prometheus application. I forgot to mention a very important field under the containers. So after the image, just type this field called image pull policy. So for this, you need to specify if not present. So what does this mean? So in case if this image is not already available inside your Kubernetes cluster, then this image will be pulled. Otherwise, the image will not be pulled. So this field is also very important. So now we have created the deployment configuration for the Prometheus. So let's create this deployment. We can create this deployment by using the kubectl command, kubectl apply file. So just copy the path of this file. So basically we can just copy from path from content root, and then so now this deployment is created. So if you want to cross check this thing, just go to the terminal and type 𝐃𝐄𝐒𝐿 get deployments. So you can see like the deployment is created, and you can see 2 by 2. This means we have specified 2 replicas, that is 2 pod instances for this deployment. So both the pods are running and both the pods are up and running. That is, both are not in failed state, they are in running state. So if you want to check the pods, just type 𝐃𝐄𝐿 get pods. So you can see like 2 pods are running. So now we have deployed the Prometheus server application. So how we can add a target to Prometheus, that is how we can make Prometheus to monitor any system that we want. So this can be done by changing or editing the configuration file of a Prometheus server. So where this file is located, if you go into this image that we used for pulling the Prometheus Docker image, you can see the information about the configuration file. So basically this configuration information is stored inside a file called prometheus.yaml, which is found inside this path called op, bitnami, and so on. So let's cross check this thing. So now let's log in into any one pod and check for this file. So you can do this via kubectl by typing the command kubectl exec stdin tty, and then pod name. We can select any one pod, and then we are going to log in via the bash mode. So we have logged into this thing. So if you type pwd, you can see the path. So the path is actually opt bitnami prometheus and then config. If you type ls, we can see conf. Let's go into the conf, and finally you can see the Prometheus YAML file. So this file contains all the systems that are currently monitored by Prometheus. We can also, we also call this as targets, that is the systems that are being monitored by Prometheus. We call this also as targets. So this is the configuration file of the Prometheus server. So if you look into this field called scrape configs, you can find all the systems that are being monitored by Prometheus. So currently there is one system that is being monitored by Prometheus, which is the Prometheus itself, that is Prometheus monitors itself. If you see the localhost 9090, that is Prometheus, right? Okay. So alternatively, you can also check this thing via lens. So if you go to the lens, so if you look into the pods and select the namespace DEM, you can see what are the pods running. So what and all you are doing via kubectl, you can also do via lens. So you can also check the deployments. So we have this Prometheus deployment already created. So now let's log in into any one of the pod. So on the top right corner, you can see something like pod shell. Just click this thing. So if you type pwd, you can see this path. So we have this c config and then prometheus.yaml file. So you can also use lens like this instead of typing everything via kubectl. So the next thing is we can also check the logs of the pod. Logs are useful if you want to debug the pods in case if there is a failure in the Prometheus deployment of an application. So just type kubectl logs, and then you can select any one Prometheus pod. So I'm just going to select this pod and then type logs. So you can see this log. Yeah. So what is what is the status of the Prometheus pod? So you can see that Prometheus has started running, and then it is already ready to receive web request. Alternatively, via lens, you can just check this thing by clicking into this pod, and then if you look here, you can see this pod logs. If you select this thing, you can also view this information via lens. So it's very easier to inspect a Kubernetes cluster via lens than using kubectl. The next thing we need to note is the directory that Prometheus uses for its storage. So the first information is we checked which directory or which file this image of Prometheus is using to store its configuration. Similarly, we need to understand which directory that this image of Prometheus is using as its storage directory. So what is actually a storage directory in Prometheus? So storage directory is the folder or the path inside the Prometheus server that Prometheus uses to store the metrics of the system that it pulls. So for example, if you are monitoring any external systems like a database or Kafka by means of Prometheus, then Prometheus pulls these metrics and then stores these metrics inside this directory that it uses for its storage. So this image is using this path as its storage directory. We are not going to make any changes to this directory. However, there is one drawback with this approach. So now we have like two pods for our Prometheus server application. So imagine that both of these pods crashes. So when we restart the pod or when we create a new pod, what will happen is all the information or all the metrics that Prometheus has pulled from the target system and stored inside this directory will also be eventually lost. So this is not, this information is not really persisted anywhere after the pod gets crashed. So one way to avoid this is by means of using Kubernetes volume. So if you go and type Kubernetes volume, so this link provides all the information about Kubernetes volume. So what is actually a Kubernetes volume? So Kubernetes volume allows you to mount the directory present inside a pod to the directory present inside the node. So whenever you are deploying a pod inside a Kubernetes, this pod will be running inside the Kubernetes node, right? So when you use volume, all the changes that Prometheus is making to this storage directory will be actually reflected inside the same directory available inside the actual Kubernetes node. So whatever changes that the pod is making will actually be persisted inside the node. But what happens if the node itself crashes? Then this information will be completely lost when you bring a new node to the Kubernetes. So how to overcome this situation? So the best way to overcome this situation is by using persistent volume for your Prometheus storage directory. However, I'm not going to cover the concept of persistent volume in this video. So whatever I'm doing is not applicable for production use cases, but you can use it for development and testing and replicate the same idea for the production by means of using persistent volume. So I have provided a link in the description that contains information about how to use persistent volume for the Prometheus storage directory. For now, I'm going to leave it as it is. So we have completed all the steps related to the Prometheus deployment. So before I proceed to the next step, I would like to show where this image is actually present. Where the image of the Prometheus is actually present. So as I said, our minikube is running inside the Docker container, right? So if you type docker ps, you have a Docker container running, which is basically the minikube. So if you want to check the Docker images for Prometheus, you have to actually go inside the Docker container where minikube is running. So you can type docker ese interactive mode and then the container ID and then in bash mode. So now we are inside the Docker container where minikube is running. Now if you type docker images, you can find all the images that is already available inside the minikube. So we just pulled this Bitnami image, right? So I've already I've pulled out this image already. So that's why you see like 2 days ago, 3 weeks ago and all those things. So all these images are available inside the minikube, which is actually running inside a Docker container. Now the next step is, after the Prometheus deployment, we need to create the Kubernetes service for Prometheus. So let's do it now. I'm going to create one more file called Prometheus service.yaml. So let's take a sample configuration file for Prometheus service. So let's go to this Kubernetes link and search for service. So you can find something like service. So let's copy a sample service configuration file and type in, copy and paste in Prometheus service.yaml. So now we have to start changing all these field names inside the YAML file. So the first one is API version. Let's leave it as it is. And the second one is kind. Of course, we are going to deploy a Prometheus service. So let's leave it also as it is. And the next one is metadata. So just like deployment, service also contains two different part, which is metadata, and the next one is specification. So under metadata, we have to name the actual name for the Prometheus service. Let's call it as Prometheus service itself. And then we are going to deploy this service inside the namespace that we created, which is DEM. So similar to deployment, we can also create a label for the Prometheus service. So let's create labels and then app. Let's call it as Prometheus, because we are using this label name called Prometheus to identify all the components related to Prometheus deployment, Prometheus server application. So the next field is specification. So under specification, the first thing that we need to enter is type. So that is the type of the service that we want to create. Basically, there are a couple of types of services. So if you look into this page for the service, you can find this information. So let me go and search for it. So you can see all these service types like cluster IP, NodePort, load balancer, and external name. So cluster IP is the default service. So cluster IP is a kind of service that is accessible only within the Kubernetes. If you want to create a service of type cluster IP, you don't have to specify anything here. You can leave it as it is because by default Kubernetes creates a service of type cluster IP. But now we are going to let us create a service of type NodePort. So we have to create NodePort. So what is actually a NodePort service? So NodePort service opens a port on the node where this pod is running. So this service can be accessed by using the IP address of the node of the Kubernetes cluster where this service is actually running. So let's call it as NodePort. Let's create the service as NodePort service. And under the selector, we have to specify the app. So our app is Prometheus. That is, we are going to basically create this service for the Prometheus app, right? So that's why we have to specify the app Prometheus, this label, because we used this label for the actual Prometheus application. And then we have to specify information about port. So there are three fields like protocol, port, and target port. So protocol is TCP by default, and the target port is the port on which the Prometheus application is running. So our Prometheus application is running on the port 1990. So we are going to create a service for an application that is running on the port 1990, and we want this service to run on another port, because when we are going to access this service, we have to specify the port ID that we specify here in this field. So when we access the service will redirect the access to the actual pod that is running on the port 1990. So let's run on the service on this port called 1991. So now we have created the service for the Prometheus. So let's deploy this service. So we can deploy using the same command, that is kubectl Prometheus service. Oh, sorry. So our Prometheus service is now created. So if you go to Lens and go to the services and select the namespace DEM, you can see that the Prometheus is now running as a NodePort service. Sorry, and this Prometheus is now running on the, this service is running on the port 1991, but we can access this on the internet via the port 32714. So how we can access this via the internet? As I said before, NodePort opens a port for the service on the node where this service is actually running. In our case, we are using minikube, which is actually a one node Kubernetes cluster. Basically, it contains only one node. So this service must, this NodePort service must be running on this node of the minikube. So how we can find a way to access this service? For this, we need to find the IP address of the node, which is basically the IP address of the minikube. So if you go and type minikube IP, you can find the IP address of the minikube. So you can access this service by means of the IP address of the node. So if you go to this thing, type the IP address of the node and then the port. So the port information is 32714. So this is the port on the node where, this is the port opened by the Kubernetes on the node for accessing this service. Okay, so 32714. 32714. But you see nothing is happening, right? So what's the reason behind that? This is because we are running minikube using driver as a Docker. So basically our minikube is running inside the Docker container. So this IP address is nothing but the IP address of the minikube running inside the Docker and not inside our actual local machine. So in case if you have installed a minikube inside a virtual box, then you can access this NodePort service by means of this IP address that is returned when you type minikube IP. But in our case, our minikube is running inside a Docker, so we cannot access this IP address which is limited within the Docker outside the Docker. So for this purpose, we have to create a tunnel for accessing this NodePort service. So what is actually a tunnel? A tunnel actually routes a IP, or it creates a routable IP between a Docker container and the actual local machine where the Docker container is running. So for this purpose, we have to type minikube service Prometheus service, which is running inside the namespace DEM. Oh, I'm sorry for this. Minikube and then service Prometheus service. So when you execute this command, now you can see that it's starting, the minikube is starting a tunnel for the Prometheus service. So basically your Prometheus service is running inside the minikube on the IP address, but this IP and this port 32714, but this whole address is limited within the Docker container where the minikube is running. So when you start the tunnel using the command minikube service Prometheus service, what will happen is a tunnel will be created, and this tunnel will route the IP between the IP inside the Docker container and the IP inside the local machine. So now we can access this service in the internet using this web address, so which is nothing but localhost and on the port 49274. So what I'm going to do is I'm going to type localhost. Okay, it is already opened, so you can see 127.0.0.492.74, which is basically the IP routed by the tunnel from this IP inside the Docker. So now you can see that we have the service for the Prometheus created, and if you go to the targets, you can see the list of systems that Prometheus is currently pulling the metrics for. So we already checked the Prometheus configuration file, and we saw that Prometheus is monitoring itself. So Prometheus is now monitoring its own performance. So that's why you see localhost 9090. So inside localhost 9090, Prometheus is actually running. So all the metrics by default, will be scrapped using this path /metrics. So now we have created the service for the Prometheus. However, if you don't want to use NodePort, if you don't want to open a port inside the node of a Kubernetes, you can actually create a load balancer service instead of a NodePort service. So for creating load balancer service, we can just type load balancer instead of NodePort, and then leave it as it is. So what I'm going to do now is I'm just going to stop this tunnel. So now I'm going to again apply the same service file. You can see that Prometheus service configured, which means we changed the service from the NodePort to load balancer, right? So it has applied this this change. So load balancer is always the best way to create a service. So now let's check our service 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐿 get services. So you can see now Prometheus service load balancer. But if you can, when you create a load balancer service, now the service can be accessed via the internet. But when you see this external IP, this external IP contains the address that you use to access the service via the internet. Okay. So now when you see the external IP, it is coming as pending. This is because when you create a load balancer service via minikube, you have to create, open a tunnel for the load balancer to be accessed. So that's why, you need to start a tunnel, just like how you did for NodePort. You can also create a tunnel for load balancer. So just type minikube tunnel in another terminal. So now you started a tunnel. So now if you go and type the same command, you can see now the external IP is allocated. So now you can access the Prometheus load balancer service on the internet by using the IP address which is nothing but localhost and the port 1991 directly. So if you go and type localhost 1991, so which is this port, you can see, I'm sorry, so let me type this localhost 1991. So now you can see this Prometheus now accessible via localhost 1991 directly. But if you look into the Prometheus load balancer service, you can see that this port is still there. So how to, I mean this port we opened for NodePort, right? So we don't need this NodePort, I mean the port for the NodePort anymore, because we are not going, I mean we are not using the NodePort service anymore. We are using the load balancer service. So if you don't want to open a port on the node for the load balancer, you can just do this by typing, by entering a field called allocate load balancer node ports is equal to false. So I'm going to apply the service again. I'm sorry, I think I did some mistake. Allocate load, so L should be in capital. So let me apply this thing again. So now you see Prometheus service is again configured. But if you check the services, you can still see the port that we opened for the node port. Why this is the case? This is because when you change a service from node port to load balancer, the port that is allocated for the node port already will be, will remain allocated. We cannot deallocate it. So if you want to deallocate this thing, you have to first delete the service and recreate the service. So let's first delete this thing. So we can simply delete by using the command 𝐃𝐄𝐒𝐑𝐈𝐏 and specify the input file. So now if you look into these services, there we don't have any services. So now let's recreate the load balancer service. So the load balancer service is created. If you go and type this command, now you can see the load balancer service is created, and now you don't see this port that we created for the node port anymore. Okay, so that's how the node port and the load balancer concept works. So just make sure that when we create a load balancer service, we specify this field that is allocate load balancer node port as false, in case we don't want any port to be opened on the node of the Kubernetes cluster. So now we have finished both the steps for deploying the Prometheus, which is basically we created the deployments for the Prometheus, which launched the Prometheus application, and then we can access this Prometheus application by means of the service which we created as a load balancer service, and this is accessible via the localhost and on the port 1991. So when you access the service via the port 1991, the load balancer service will actually redirect this access request to the actual pod that is running on the port 1990. So now we have completed deploying the Prometheus application inside Kubernetes. Next, we will see how to deploy a NodeExporter application inside Kubernetes. So what is actually a NodeExporter? A NodeExporter is nothing but a Prometheus exporter application. So what is then a Prometheus exporter? If you look into the UI of the Prometheus server, you can now see that Prometheus is scraping the metrics of its own. That is, these metrics of the Prometheus that the Prometheus service is scraping is available on the /metrics path in Prometheus metrics format. That's why the Prometheus server is able to scrape the metrics from this path. So if you want to scrape the metrics or pull the metrics from a system that you want to monitor, then these metrics should be available in /metrics path in Prometheus metrics format. But not all the systems will be able to ship the metrics in Prometheus metrics format. In such cases, we will use an application called Prometheus exporter. So Prometheus exporters are libraries written in Golang. So these Prometheus exporters are used for extracting the metrics of any third-party system in Prometheus metrics format and then ships these metrics to the /metrics path. So if there is a system that you would like to monitor and this system doesn't expose the metrics in Prometheus metrics format, then in such cases you can install the Prometheus exporter application inside your machine, and then you can extract the metrics of the third-party system that you would like to monitor and then ship the metrics to the /metrics path. So Prometheus exporters are available for various types of third-party applications. For example, databases like Postgres, Oracle, or messaging systems like Kafka, or even for applications like Confluence and Bitbucket. So what is actually a NodeExporter? So NodeExporter is actually a Prometheus exporter that is used for exporting the metrics of a Linux system. So mainly metrics related to hardware and kernel. So in case of Kubernetes, these node exporters can be used for exporting the metrics of all the nodes available inside our Kubernetes cluster. So today in our video, we are going to deploy this node exporter application and then export the metrics of the nodes inside our Kubernetes cluster. So by default, NodeExporter exposes the metrics on the port 9100/metrics path. So now we will see what are the steps that are needed to deploy the NodeExporter application inside Kubernetes. So the first step is we need to create a Kubernetes daemon set for the NodeExporter. So what is Kubernetes daemon set? So Kubernetes daemon set makes sure that one instance of the application that we would like to deploy inside the Kubernetes cluster, which in our case is the NodeExporter. So Kubernetes daemon set makes sure that one instance of the NodeExporter application is running on all the available nodes inside your Kubernetes cluster. So for example, if your Kubernetes cluster has 2 nodes, then deploying the NodeExporter application as a daemon set will make sure that 2 pods are created and running, one on each node. So in the future, if you are adding one more node, then there will be one more pod of the NodeExporter will be created and running inside the Kubernetes. So that's the reason we wanted to deploy the NodeExporter application as a daemon set and not as a deployment, because we want to export the metrics of all the available nodes inside the Kubernetes cluster. The next step is we need to create a Kubernetes service for the NodeExporter. Why we are doing this? We are using minikube, which is basically a one node Kubernetes cluster. So what I'm going to do is I'm going to create a Kubernetes service for the NodeExporter application running inside that one node, and then I will add this service as the target to the Prometheus. In case if your Kubernetes cluster contains more than one node, then the best way to do that would be to add the endpoints of all the nodes as the targets to the Prometheus rather than the service. We will see all these details later in this video. Now we will start implementing both these steps for deploying the NodeExporter application inside the Kubernetes. So let's go back to this directory and then create a new folder called NodeExporter. And first thing is we need to create a daemon set. So let's copy the deployment of Prometheus as it is and then paste inside the NodeExporter. Rename this as NodeExporter daemon set, because we are going to deploy the NodeExporter as a daemon set and not as a deployment. So let's replace all the necessary fields. So we are going to create a daemon set for the NodeExporter and not a deployment. So let's name it as a daemon set, and then the name would be like NodeExporter daemon set. The namespace will be DM, data engineering minds, and then we have to create a label. So the app name would be NodeExporter, and then we since we are going to deploy this as a daemon set, which means like one pod will be created on all the on all the available nodes. So we don't have to specify anything like replicas inside the specification, and then we have to make the configurations for the pod. So first thing is metadata. So inside the labels we have to name it as NodeExporter, and then specification for the containers. So let's call it again as NodeExporter, and then we have to find the Docker image for the NodeExporter. Let's go back to this Docker hub and then search for NodeExporter. So you will get something related to NodeExporter. So I think we have to use something like Prom NodeExporter. Okay, so we have to use this image. This is the most reliable image for the NodeExporter, I would say. So this image is available in Prom and NodeExporter path. So let's copy this thing and paste inside the image field. We are going to use the latest version, and then image pull policy will be if not present, and then port, the container port by default will be running on 9100, and also the node exporter will be shipping the metrics of the node and it will put the metrics on this port 9100/metrics path. But if you want to use a different path for shipping the metrics, then this can also be done by adding an argument. So for this thing, let's add this field called args, and then we have to create add a parameter called web.listen.address. So this means we are going to, the node exporter is going to ship the metrics of the node, of the Kubernetes node, and then it will ship the metrics to a different port than 9100. So let's ship the metrics to a different port. Let's do the shipping on the port 9250. Okay, so now we have specified the configurations for the node exporter pod. So now we need to map this pod to this, the pod called NodeExporter to this daemon set called NodeExporter daemon set. We can do this by changing the labels, the match labels inside the selector specification of the daemon set. So inside the match labels, we need to match the app called NodeExporter, not Prometheus. So NodeExporter. So now we have created the configuration for the daemon set. So we have specified the metadata field for the daemon set, and then we have specified the template for the node exporter pod, and also we have mapped the the daemon set and the pod for the node exporter. So let's create this daemon set. So we can do this by means of kubectl apply f, and then NodeExporter daemon set.yaml. So the daemon set is created. Let's cross check this thing, and if you go to lens and go for the daemon sets inside the namespace dem, now you can see that daemon set is created and it contains one pod, because we are using minikube as I mentioned before, and minikube contains only one node, which means the daemon set will create one pod that is running on this one node. So if you go to the pods, you can see that this pod node exporter daemon set is created. So now we have successfully created the node exporter application. So now the next step would be to create a service for this node exporter. So we finished creating the daemon set. Now we will create the Kubernetes service for the node exporter. So let's create a file called NodeExporter service. Let's copy this Prometheus service.yaml and rename it as NodeExporter service.yaml. The configurations for the service is the same as the one for the Prometheus service. So let's rename this Prometheus service as NodeExporter service. Namespace would be DEM, but the app name would be NodeExporter, and then the type of the service we can create a cluster IP service, because we are not going to access the node exporter via internet. This node exporter is applicable for access only by the applications running inside Kubernetes and not outside the Kubernetes. So that's why we create the service as cluster IP. So this field is not needed. And then selector, so we are going to create the service for the node exporter app. So let's call it as node exporter, and then the port. So the target port for which we want to create this service is 9250, because we are shipping the metrics on the port 9250 and not on 9100. So 9250, and the port where this service has to run. So let's use the same port. So let's use the same port 9250. So now when any application calls the service via this port 9250, then this node exporter service will redirect the access to the actual node exporter application that is also running on the port 9250. So now we finished configuring the service for the node exporter. So let's create this node exporter service. So just like how we created the daemon set, we have to just do kubectl apply and node exporter service. So now we have created the service for the NodeExporter. So if you go to Lens and go to services, you can see this NodeExporter service. So you can see NodeExporter service is running as cluster IP, whereas the Prometheus service is running as load balancer. So if you go and type 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐿, I mean like type 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐿 get endpoints. So you now see this NodeExporter service contains one endpoint, which is the endpoint of the pod running on the port 9250. This is because we are using minikube, right? So basically the NodeExporter service is running for the NodeExporter application running on this one node. In case if your Kubernetes cluster contains like more than one node, for example 2 nodes, then we will definitely have like 2 pods of NodeExporter running, and then there will be like 2 different endpoints applicable under the NodeExporter service. So as I said before, we have deployed this NodeExporter service as a cluster IP service, which means this service can be accessible only by the applications running inside Kubernetes. But in case if you want to access this service on your local machine just to check what are the metrics being exported by this NodeExporter service, then we can do this by means of port forwarding. So we can port forward this service to our local. So the syntax to do the port forward would be like 𝐾𝐄𝐒𝐿 port forward service NodeExporter service. So we are port forwarding the NodeExporter service to our local machine. So it is running on, I mean we want to port forward on the local machine on the port 9250, and this service is also running on the port 9250 on the Kubernetes. So the namespace would be DEM. So now the NodeExporter service on the Kubernetes, which is running on the port 9250, is also, I mean like, is port forwarded to our local machine also on the port 9250. So now you can access this service locally just to check what are the metrics that are being shipped by this NodeExporter service. So just go and take localhost 9250. So you can see this metrics path. So inside this metrics path, you can see all the metrics in Prometheus metrics format exported by the NodeExporter application for the Kubernetes node. So basically the NodeExporter application that we deployed inside Kubernetes is shipping all the metrics of the node of our minikube cluster, and then it ships these metrics to the port 9250/metrics path. So we have port forwarded this service from the Kubernetes to our local just to check how this metrics looks like. So I will now close this port forwarded service. I will also stop the port forwarding. With this, we have completed deploying the NodeExporter application inside the Kubernetes cluster. Now we will see how to add this NodeExporter application as a target to the Prometheus. The first step would be to create a service account, cluster role, and cluster role binding for the Prometheus application. So why we are going to do this thing? If you look into this NodeExporter application that we just deployed, so we deployed a NodeExporter daemonset which created one pod for the NodeExporter application, and then we created a service for the NodeExporter application. So now if we want to monitor the NodeExporter application by a Prometheus, then we can hard code the name of the NodeExporter service to the Prometheus target. But this is not the best way to do so. This is because normally when you deploy a Prometheus application inside your Kubernetes cluster, you want your Prometheus to monitor all the resources of the Kubernetes cluster like pods, nodes, services, and so on. So every time you cannot go and hard code the service name or the endpoint of a node to the Prometheus target. So the best way to do this would be to allow the Prometheus application to access all the resources inside the Kubernetes cluster that you would like to monitor. So that's what we are going to do now. So basically we are going to create a kind of role-based access control for the Prometheus application. So the first step would be to create a service account. So what is actually a service account? So normally Kubernetes contains three different types of entities. One is called as user, the second one is called groups, and the third one is called service account. So the service account is an entity that will be used by a pod to authenticate to the Kubernetes cluster. So normally when you create a pod, this pod will authenticate to the Kubernetes by using a service account. So every namespace by default will have one service account. So if you type like 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐿 service accounts, so you can see like there is a service account inside the namespace data engineering minds, so default. So when you create an application, for example, when you create for example like NodeExporter or Prometheus, whatever it is inside this DEM namespace, then the pods will be using this service account default for authenticating to the Kubernetes cluster. So you can also create your own service account and tie this service account to the deployment configuration or to the daemonset configuration, so that the corresponding pod will be using the service account that you created to authenticate to the Kubernetes cluster. So that's what we are going to do now. So let's go to this folder and create a file called Prometheus RBAC.yaml. So we are going to create first the service account. So let's go to this Kubernetes and check for a service account. So you can see something for the service account, right? So let's copy this thing and let's go to this file that we just created, and then the kind will be service account and the metadata will be the name will be like Prometheus service account, because we are going to create a service account for the Prometheus application and then create some permissions for this service account. Okay, so the first step would be like to create the service account itself. So the name would be Prometheus service account and the namespace would be DM. So we don't want we don't have to provide this field. So the next step would be to create a cluster role. So why we are doing this thing? So cluster role basically defines all the permissions that we would like to create across the entire cluster for an application. So let's go to this Kubernetes page and then search for cluster role. So let's copy this as it is. So I'm going to create the service account and the cluster role all in the same YAML file under role-based access control RBAC. So if you want to create more than one different types of configuration, Kubernetes configuration in a single file, you can separate them by using three dashes. So I'm going to paste this cluster role. So the kind is cluster role. So what is actually a cluster role? So cluster role actually defines the permissions that you would like to create for any application across the entire cluster. So it is not tied to any namespace, because you're basically going to create permissions for the Prometheus application across different types of Kubernetes resources like services, pods, nodes, whatever it is in the entire Kubernetes cluster. That's why we don't need to specify any namespace, and the name would be like I would say like Prometheus cluster role, and then rules. So under the rules we need to specify what are the Kubernetes resources that we would like to give permissions or access for the Prometheus application. So the first one is API groups. So normally you have to provide the API groups. You cannot skip this one. So API groups are nothing but the API groups available inside Kubernetes cluster. For example, if you look into this Prometheus deployment, the API group for the deployment that we used is apps. Similarly, for NodeExporter daemonset, we used apps, right? So there are several types of API groups. So if you specify an empty field, this means a permission will be created for accessing all the types of API groups available inside your Kubernetes cluster. Normally you cannot skip this field. And the next one is resources. I will leave this field as it is. Okay, so now our Prometheus application will be having access to all the API groups. So the next one is resources. So resources are the Kubernetes resources that we would like the Prometheus application to have access to. Okay, so in our case, we want our Prometheus to monitor the NodeExporter, which is accessible via the NodeExporter service, right? So which means we want our Prometheus to have access for the services inside the Kubernetes cluster. So that's why I will put resources as service. Okay, so in case if you want to allow the Prometheus to also access pods and nodes, you can now specify like this pods, nodes, and so on. Okay, so but I am going to monitor only the service, right, the NodeExporter service. So I will limit only with services. And then with the verbs specify what types of accesses you would like to give for these resources. So I will if you specify get, watch, and list, so these three permissions will allow the Prometheus to read the metrics available from all the resources. Okay, so these three things are already enough if you want the Prometheus to just read the metrics available from these resources. So we can leave it as it is. So now we have created a service account for the Prometheus, and then we have created a cluster role and defined the set of permissions that we want to want to create for the Prometheus service account. So now we have to make sure how we can allow Prometheus service account to have access for all the permissions that we have created in the cluster role. So for this purpose, we need to create one more Kubernetes configuration, which is called as cluster role binding. So if you go and search for cluster role binding in this page, you can find some examples. So I'm going for the cluster role binding example here. So I'm just going to paste this as it is. So the kind would be cluster role binding. So cluster role binding, just like the cluster role, is not tied to any namespace. So the metadata, under the metadata, the name would be like, I would name as Prometheus cluster role binding. So now what we are going to do is we will bind this cluster role for this service account that we created for the Prometheus. So we are going to bind the Prometheus service account. So under the subjects, we have to put service account, because there are three types of subjects as I mentioned earlier: users, groups, and service accounts. Here we are going to create the cluster role binding for the service account. So that's why it needs to be service account, and the name of the service account that we want to provide the cluster role binding would be Prometheus service account, or I can just copy from your Prometheus service account. And then the API group is not applicable if the kind is service account, so it would be like namespace. So this service account is created for this namespace DEM, right? So that's why we have to provide the namespace for the subject, but this namespace is not the namespace for the cluster role binding. Okay, so this is for the subject for which we want to create the cluster role binding. And then we have to specify the role that we want to bind for the service account, which is basically the cluster role that we created here. So we have to copy the name of the cluster role, the kind is cluster role, name is Prometheus cluster role, and API group stays as it is. Okay, so now we have created the service account called Prometheus service account. Then we created a list of permissions that we want to that we want this service account to have access across the Kubernetes cluster. So we are basically going to provide access for all the services inside the Kubernetes cluster to be able to be accessed by this Prometheus service account. And then finally, we are binding these permissions that we created for the service account that we created in the first step. Okay, so we can create all these three configurations in single step by 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐍 apply f Prometheus RBAC.yaml. So you can see that service account is created, cluster role is created, and cluster role binding is also created. So now if you go to lens and check under the cluster roles, so if you search for Prometheus, so you can see the Prometheus cluster role is created. Similarly, for the Prometheus cluster role binding, you can see Prometheus cluster role binding is also created. And if you go to the service accounts, you can also see under the namespace DEM there are two service accounts. One is the default one, which will be used by all the pods if you don't specify any service account inside the configuration for the pods. And then we have one more service account, Prometheus service account, which we just created. So now what we are going to do is we will be attaching this service account to the Prometheus deployment file that we created earlier. So what we are going to, so far this Prometheus application that we created via this Prometheus deployment file is using the default service account, but now we have created one new service account with some permissions. So we are going to use this service account for our Prometheus application. So this can be simply done by adding service account name Prometheus service account. So now we have completed the first step, that is we created the service account, cluster role and cluster role binding for the Prometheus application. So the next step is we will create a config map to add the NodeExporter target to the Prometheus via Prometheus.yaml file. So let's see what is this step all about. So as I mentioned earlier, we can add any target to the Prometheus server by using the Prometheus.yaml file. If you go into the pod and click Prometheus deployment and go into this terminal of the Prometheus, okay, we have this thing already opened. Yeah, so if you look into this thing, into this path that is of Bitnami Prometheus config, we have this Prometheus.yaml file which contains the configuration of the Prometheus server. That is if we want to add any system as a target to Prometheus server, then we need to change the configurations inside this file. So basically we will add the NodeExporter service as a target under the scrape configs. Okay, just like how Prometheus is added here, we will add the NodeExporter. But how we are going to do these things? Basically we need to edit the Prometheus YAML file, right? So one way to do this would be to use config map. So basically we will going to we are going to create a config map and add this Prometheus YAML configurations inside this config map, and then we will see how we can map this config map to the Prometheus deployment. So the first step would be to create a Prometheus config map. So let's call it as Prometheus config.yaml. So let's go to this Kubernetes configurations and check for config map. So click this link and then just select this example here. Okay, so we are going to create a config map for the Prometheus, and its name will be Prometheus config, and we are going to create inside the namespace DEM. We can also use labels just like how we use for deployments. So labels, and the app will be for Prometheus because we are going to create a config map for the Prometheus, right? so Prometheus. And then under the section called data, I will just remove all these things. So we are going to add the actual configurations for the Prometheus, just like this YAML file. So what we are going to do is we will add the configurations of the Prometheus server. So every configuration that we are adding inside the config map should be separated by means of key and value. So we have to add a key. So let's call this key as Prometheus.properties. So we are going to add the value as a as a string inside the YAML file. So when you want to add a string to the YAML file, you have to concatenate them by means of pipe symbol. So now we are going to add the actual configuration of a Prometheus server, where we are going to add the target to the Prometheus. So inside global, we have to specify some global parameters for the Prometheus server. Please remember, these things are specific to the Prometheus. I'm not explaining anything about these things in detail here, like the Prometheus architecture or the structure of the Prometheus configuration. So that's really not the scope of this video. So I'm just going to specify some mandatory or high level properties that we need to place inside a Prometheus configuration file. So the first one will be like global, inside global, let me specify scrap interval as 15 seconds, and then evolution interval as 15 seconds again. And then the next would be like scrape configs. So under the scrape configs, we have to specify the actual targets or systems that we want to that we want the Prometheus to monitor. So basically we want the Prometheus to monitor the NodeExporter, which is running inside a node of a Kubernetes and accessible via the NodeExporter service. So what we did already is we created a Prometheus RBAC and gave the Prometheus access to all the services inside the Kubernetes cluster, right? So now we need to find a way how we can add these services targets inside the Prometheus Prometheus configuration file. So let's call the job name for this particular target as NodeExporter. And the next one will be scheme. So scheme would be like HTTP, because we are not adding any kind of SSL security to the NodeExporter applications that we deployed. Now we have to add the actual NodeExporter service. So these services are running inside Kubernetes, right? So we have to add a field called or a parameter called Kubernetes SD configs. So what is Kubernetes SD configs? So SD stands for service discovery. So basically we are actually trying to add all the services inside the Kubernetes to be scrapped by the Prometheus. Basically we want to scrap only the services, but the service belongs to a Kubernetes, right? So that's why we have to put this field called the Kubernetes SD configs. So now we can, inside the Kubernetes SD configs, we have to specify a parameter called role. So the type of Kubernetes resources that we would like to monitor is service. So there are several types of roles, like for example, if in case you want to add a Prometheus node itself as a target, so then we have to put like node. So in our case we are going to monitor only the services, so that's the reason we have to put service. So we want to monitor the services that is available inside the namespace DEM, right? So the next one would be like we have to create namespace, and under the namespace we have to put all the namespaces under which we have to we need to create we need to scrap the services for which we want to monitor. So the namespace would be DEM. So when you specify the role as services, what will happen is, for example, if you look into the NodeExporter service, we have this NodeExporter service running in the port 9250. So what will happen? There will be one target added for this service running on the port 9250 under the job name NodeExporter. So this job NodeExporter will contain one target, which is basically the NodeExporter service running on the port 9250. In case if the NodeExporter service is running on multiple ports like 9250, 9251 for example, so then for each port of this service there will be one specific targets under the job name NodeExporter. In case if you are using endpoints, for example, instead of services, so what will happen is, under the namespace DEM, if you check in the lens and then endpoints, so under the namespace DEM we have like three endpoints, right? One endpoint for the NodeExporter service and two different endpoints for the Prometheus service. So because the Prometheus service is covering two different parts of the Prometheus application, that's why you see two different endpoints. So in total we have three endpoints. So for each of these endpoints there will be one target created under the job name NodeExporter. So this is how this Kubernetes role will work. So in our case we want to scrape the metrics only for the services inside the namespace DEM and specifically for the NodeExporter service. So when you specify services and the namespace DEM, this means the a target will be added under the job name NodeExporter for all the services inside the namespace DEM. But in our case, we want to add the target only for the NodeExporter service. So how you can do this thing? By default, Kubernetes defines a metadata label for each of the resources available inside the Kubernetes cluster. For example, just like how we define labels inside the metadata section for the deployment, Kubernetes by default also defines internal labels for all the resources inside the Kubernetes cluster, like services, pods, and all those things. So basically, if you want to filter the NodeExporter service from all the services inside the DEM namespace to be added under the NodeExporter job, then we have to apply some filter for the internal labels that Kubernetes creates, Kubernetes defined for its resources. So we can do this by means of using a concept called relabel_configs. So relabel configs is actually a very powerful mechanism of Kubernetes, which allows us to apply any filter or any modification to the labels that Kubernetes defines for its resources. So under this label configs, we have to specify something called source labels. So source labels is nothing but the labels that Kubernetes defined for its resources like services, pods, and so on. So in our case it's services. So inside this, so we have to define the label name of the service. So the internal label name of the service that Kubernetes defines are referred by means of meta underscore Kubernetes underscore service underscore name. So now we are going to apply a filter on the Kubernetes services. We want to filter the NodeExporter service, right? So what we are specifying here is, under the relabel configs, we are going to filter the NodeExporter service by specifying this label called meta Kubernetes service, which contains the service name of all the services inside the Kubernetes. So now for applying the filter, we are going to use the regular expression, which is called as regex, and we want to filter for the NodeExporter service, so which is basically NodeExporter service. So this will filter the NodeExporter service name from all the services of the Kubernetes available inside the namespace DEM. So then we have to specify one more field called action, which is keep. So what this will do is, so now from all the Kubernetes services inside the namespace DEM, we have filtered NodeExporter service. So the action keep will keep only this NodeExporter service and drop all the other services that doesn't fall into this regular expression. So basically we are filtering only the NodeExporter service from all the services inside the namespace DEM and adding the NodeExporter service as a target under the job name NodeExporter. So with this, we have finished writing the configuration or config map for the Prometheus. So let's now first create this config map. Kubernetes apply f Prometheus config YAML. So we have created the Prometheus config map. So if you go back to the lens and check for config maps, so you have the Prometheus config map created. So now how we are going to add this Prometheus configuration to the Prometheus YAML file inside the Prometheus pod. So for this purpose, we are going to create a volume. So we are going to create a volume and then refer the values of this config map inside this volume. So under the volume, we are going to refer this we are going to create a new volume which is called as Prometheus config volume. So the contents that we are going to put inside this volume will be the contents of the config map. So we have to specify config map, and then we have to specify the name of the config map that we want to put inside this volume, which is basically Prometheus config. So we define this Prometheus config map as Prometheus config, right? So that's why we have to name it as Prometheus config. And then next field would be items. So under the items, we have to specify what and all data from this config map we want to put into this volume. We want to refer into this volume. So we want to refer this Prometheus.properties. So under the items, we have to put key, and the key would be Prometheus.properties. And we want to put the configurations inside this Prometheus.properties to the Prometheus.YAML file, right? So we have to specify one more field called path, and then we have to specify the name of the file under which this configurations that comes under Prometheus.properties should be put. So Prometheus.YAML. And then we have to specify one more parameter called default mode as 420. This means we are allowing this service account called Prometheus service account to be able to write into this volume. So we are basically defining this permission, write permission for the service account via this default mode 420. We now created the volumes. Now we have to mount this volume to the actual pod that we created earlier inside the Prometheus configuration. So for this, we have to, after the port, we have to create a field called volume mount and mount this volume. So basically the volume that we are going to mount to this pod will be Prometheus config volume that we created here, and then the mount path. So the mount path would be, if you look into where this Prometheus.YAML file is located, so we can mount in the same path, which is basically this path. So we can provide this path. So what will happen is this we created a volume here, and inside this volume we are referring the values that we put inside this Prometheus.properties config map by means of key Prometheus.properties, and then we are actually referring these values, these contents, and then basically putting those contents inside a file called Prometheus.YAML, and this file Prometheus.YAML will be mounted inside this path. Okay, so that's how we are referring the config map contents inside the Prometheus pod that we have created here by means of the volume. So now we can proceed to apply all these changes to the Prometheus deployment that we created earlier. So just type kubectl apply f Prometheus deployment. So all the changes should have been applied. Let's go to this the lens, and close all the terminals that we've opened earlier. Now look into the pods here. So if you look here, the pods are getting created, the changes are getting applied. Okay, I think there is some issue. Let me check this. So I think we can just go here and then check the means of logs. Okay. Unknown role services. Okay, so seems like there is an issue. Let me go into this Prometheus config file. Okay, I think this should be service, not services. So let me apply this change to the config map. So the change is applied to the config map, and then I'm going to apply the change again to the deployment. Okay, I think it's not needed, but still I did this thing. So now let's see whether it's creating or not. Seems like there is an issue again. Let's go to this. Okay, I think things are changing. Okay, fine. So now the change that we applied, we changed from services to service, right? So after this, I think the change is applied, and then the pods are created. So now let's log into this pod of the Prometheus and go into the terminal and go to conf and then prometheus.yaml. If you look into prometheus.yaml, so you can see that whatever we added inside this config map, this NodeExporter is now available inside the prometheus.yaml file. So basically what we did is we created a config map, and then we referred the contents of the config map via the volume, and that's how we actually added the targets to the Prometheus. So now let's check the Prometheus service locally. So Prometheus is running on localhost 991, right, service. So if you go and check into the targets, so now you can see the NodeExporter service is added to the Prometheus target. So previously the Prometheus was monitoring itself, but we didn't specify the Prometheus target inside the config file. We specified only the NodeExporter service. So that's why you see only the NodeExporter service now being scraped by the Prometheus. So we successfully added the NodeExporter as a target to the Prometheus server. Now let's go back to our presentation. So okay, so we also completed this third step, right? So we created the volume for the Prometheus, and then we referred the config map contents by means of the volume. So we finally added the NodeExporter target to the Prometheus. So now we will see how to deploy a Grafana server application inside Kubernetes. This is fairly very straightforward, just like how we did Prometheus earlier. So basically the first step would be to create a deployment for Grafana, just for launching the Grafana application inside Kubernetes. And next we have to create a service for Grafana to access the Grafana UI via the internet. It's very straightforward, so we can complete this thing very quickly. So let's go back to our directory, and then let's create one more folder called Grafana. So under this, I'll just close all these files. So let's create one file called Grafana deployment. The configurations would be the same as for the Prometheus. So let's change the name to Grafana. The namespace will be DEM. The labels would be Grafana. So let's stick with just one replica, and inside and then let's configure the container part. So the name would be Grafana. Now we have to find which image we are going to use. Just go to this Docker Hub and then search for Grafana. So we have something like Grafana, right? So we are just going to make use of this thing. Okay, so let's copy this image name and then specify Grafana and then latest version. Okay, so the image pool policy would be if not null port. So by default Grafana will be running on the port 3000. So let's skip these steps for now. So first what we are going to do is we are just going to create an application for Grafana inside Kubernetes. So let's rename the app to Grafana, and then inside the selector we have to match for the applications whose label is Grafana. So we have specified all the stuffs related for the basic deployment of a Grafana server. So let's start like kubectl apply f Grafana deployment YAML. So now we have the Grafana deployment created. So if you go into the lens and check for the pods, we have this Grafana now created. If you click into the Grafana pod and then go to the terminal, so by default this particular image stores all the Grafana data sources inside this path. It's say Grafana provisioning and then data sources. Okay, so basically if you want to add any new data sources, like if you want to add the Prometheus as a data source inside Grafana, then you have to add all the Grafana configurations inside this path. Similarly, this image uses this folder called cd where live and Grafana as the backend for this Grafana database. So basically Grafana database contains all the information related to the Grafana server. For example, what are the data sources that we have added to the Grafana, like Prometheus and similar other data sources. What are the information about the users who have logged in into the Grafana. So all this information will be stored inside the Grafana database, and this Grafana database by default will be stored inside this path by this particular image that we are using. So just like for Prometheus, if you want to install or deploy Grafana inside Kubernetes for the production use cases, then you have to use a persistent volume for this thing. For now, I'm not going to make any changes to how this storage directory is implemented in this image, but in case if you want to use for production use cases, then you have to use a persistent volume. Otherwise, whenever your pod for Grafana crashes, then when you create a new pod or when you restart the pod, all the information stored inside the Grafana database will be lost. So that's why you need to use a persistent volume for the storage directory of the Grafana, similar to how similar to what I said for the Prometheus storage directory. So now we completed creating this Prometheus Grafana application inside Kubernetes. The next step would be to create a service for the Grafana. So let's do this thing. Just we can copy the stuff that we did for Prometheus service, just paste it here, rename it as Grafana service. So the name would be Grafana. So the app name would be Grafana as well, and we can use the same type of service, that is the load balancer service, because we want to access the Grafana UI from the internet, right? So that's why we stick to the load balancer service, and allocate load balancer node port would be false, and the selector we are going to select the Grafana app, and Grafana is running on the port 3000. So let's run the service on the port 3001. So this is all about creating the service. It's fairly straightforward. So let's apply this thing as well. So the Grafana service is also created. So if you go to the lens and go and check for the services, you can see the Grafana service is created. So now you can access the Grafana service via the internet by means of localhost. So if you look into this thing, Grafana service is external IP is 127.0.0.1, which is basically the localhost, and it's running on the port 3001. So let's go to this port localhost 3001. So now you can see the Grafana is available. So we have finished creating deploying the Grafana applications at Kubernetes, and also we created a Grafana service. So now how we can add the Prometheus as a data source to Grafana service. So for this purpose, the next step would be to create a Grafana config map, and then we can add the Prometheus as a data source to the Grafana server. So similar to what we did for the Prometheus config map, we are going to create a config map for the Grafana. So let's go back to our directory and then copy the config map that we created for Prometheus, and let's create now for Grafana. So inside the Grafana, we have to rename as Grafana config, and it should be in the namespace DEM. The app would be Grafana, and now we have to add configurations. That is applicable for a Grafana related configuration syntax. Okay, so let's call the key name as Grafana data sources, because we are going to add the list of data sources to the Grafana server, which is basically we are going to add the Prometheus as a data source here. So we are going to add string contents to the YAML file, so that's why we have to concatenate everything by means of pipe symbol. So as I said just now, we have to add the configurations in a syntax applicable for the Grafana configuration. So the first field would be API version. So please remember, I'm not adding all the configurations applicable for a Grafana server. I'm adding only very high level configurations or very mandatory configurations that is already enough to add the Prometheus data source. So the API version would be 1. So next field would be data sources. So the data sources we are going to add is Prometheus, which is basically we are going to create dashboards for all the targets being scraped by the Prometheus. So let's call the name of the data source as Prometheus targets. So type of the data source is Prometheus, and the next one is org ID. So you can define any ID you would like. So I will just say like 1, and then the URL of the Prometheus data source. So basically we need to add the service of the Prometheus as a data source here to the Grafana config, so which would be HTTP. So name of the Prometheus service is Prometheus service, right? So name is Prometheus service, and it is available inside the namespace DEM, and it's a service, right? So that's why we call it as SVC, and it's running on the port 9091. So let's call the version as first version. So now we have added the configurations for our Grafana data source, which is basically we are going to add Prometheus as a data source to the Grafana. So let's create this config file, 𝐃𝐄𝐿 apply f Grafana config. So the Grafana config is created. So now we will refer the contents of this config map inside the Grafana deployment by means of volume, just like what we did for the Prometheus. So let's open the Prometheus deployment. Just copy this volume that we created here and paste it under the Grafana deployment. I think it should be coming as the same line as containers. Okay, so the name that we created is Grafana config volume. The config map default mode would be 420 and the name of the config is Grafana config. Under the items, the key name is Grafana data sources. So let's copy this thing and we are going to put inside the file called Grafana YAML. And now we created the volume. We will mount this volume under the container configuration. So which is basically volume mounts name. So the name is Grafana config volume and then mount path. So basically we are going to mount this file Grafana YAML inside the directory that this particular image is using for specifying all the data sources. We saw this earlier. So which is basically 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐿 Grafana provisioning data sources. So we just put this thing here. So now we have finished referring the contents of the Grafana config map, which is basically the configuration of a Grafana server inside the Grafana deployment. So let's reapply the deployment for Grafana. So now that the Grafana deployment is configured, let's close this thing and let's go to the deployment. So if you see, the Grafana deployment is configured again. That's why you can see like 12-13 seconds, which is it is configured just now. So let's go to the terminal and let's go to this particular path. So if you see, now we have a file called Grafana YAML, and this file should contain all the stuffs that we entered inside the Grafana config.yaml. So now we have added the Prometheus as a data source to the Grafana. So let's check this thing. So when you are logging into the Grafana for the first time, you have to log in by means of admin username, and then you have to create any password, whatever you want. Of course, you can also specify this information inside the Grafana deployment by means of Kubernetes secrets, but I'm not doing that now. I'm just making it very simple. So when you enter this thing, you're logging into this Grafana user interface by using the admin username. So whatever you're entering here will be stored inside the Grafana database that I showed earlier, which will be available inside where live Grafana. So I explained about this Grafana database, right? So whatever information you used for logging into the Grafana server, which is the admin username, this information will be stored inside this Grafana database. So now we have created the Grafana database. Let's go into the data sources so we can see Prometheus targets, right? So we added this Prometheus target, so which is also available here. So now we have to start creating the dashboard for the NodeExporter. So basically we can do this by going to the Google and check for Grafana dashboard for NodeExporter. So you can do in two different ways. One is you can copy the JSON file available for the NodeExporter, or you can simply copy the ID. I mean, like, you don't have to create the dashboards explicitly from scratch, because NodeExporter is a very commonly used application. So some commonly used dashboards are already available for Grafana on the internet. So you can simply make use of those dashboards instead of creating your own dashboards from scratch, which makes the life very simple. So I'm just copying the dashboard ID and then going to the Grafana, and then I just have to go to this import and then paste this Grafana ID, dashboard ID, then press load. So under this Prometheus, you have to select the Prometheus targets, because this targets is already added by means of this Grafana config, and then you have to import. So now we have the dashboards created for the NodeExporter. So we have created these dashboards for the NodeExporter service that we added as a target to the Prometheus. So if you look into the Prometheus, we added this NodeExporter service as a target, right? So that's why you can see on the dashboard the system that we are basically creating the metrics for. So you can see all the available metrics inside this dashboard. So please remember, so you can see here only one NodeExporter service, right? Because we added the service as a target to the Prometheus. So as I explained before, we are using minikube, which basically contains only one node. So that's the reason why I created a service for that node and then added the service as the target. In case if your Kubernetes cluster contains more than one node, then as I explained before, the best way would be to add that endpoint as a target to the Prometheus. So for this purpose, what you can do is you can just go to this Prometheus config, and instead of service, you can add endpoints here, and then inside the source labels, instead of service name, you can just put endpoints name, and you don't have to specify any NodeExporter service or regular expressions, whatever it is. Yeah, so you can just skip this thing. You can just put Kubernetes endpoints name, and inside the RBAC, so since it's an endpoint, we have to specify endpoints as well. Okay, so you have to create the access for the Prometheus service account as endpoints, and then inside the Prometheus config, you have to specify the role as endpoint. So if you do this thing, in case if your Kubernetes cluster contains more than one node, then what will happen is all the nodes will be added as targets to the Prometheus, and then inside the Grafana, under the job name NodeExporter, you can see the metrics available for all the individual nodes. But in my case, as I said earlier, I have only one node because I'm using minikube, and that's the reason I have added the service as a target instead of the node's endpoint. So with this, we have finally come to the end of today's discussion. So just to summarize, first we prepared the setup for our Kubernetes cluster, which is basically a minikube, and then I showed how to inspect your Kubernetes cluster via the Lens UI, and then we deployed a simple Prometheus server application inside Kubernetes, followed by we deployed a NodeExporter application inside Kubernetes. We also saw what is actually a NodeExporter application and how it can be used to export the metrics of a Kubernetes node. And then we added this NodeExporter application as a target to the Prometheus. And finally, we deployed a Grafana server application inside Kubernetes, and then we created the dashboards for viewing the metrics of the NodeExporter via the Grafana UI. Finally, thanks to everyone who watched this video. I hope you understood all the things I explained so far today in this video. In case if you have any questions, please feel free to mention them in the comment section, and I will try my best to respond to them as soon as possible. Thanks once again.